The most significant piece of evidence that we have in this entire ancient astronaut puzzle is Puma Punku in the highland of Bolivia.
12,800 feet up in the Bolivian Andes, scattered across a windswept plateau, sit stones that should not exist. They're called Puma Punku H-blocks, carved from andesite, one of the hardest rocks on Earth. Cut with surfaces flat to 0.05 millimeters, corners locked to within 1/10 of a degree, grooves so precise they look machined. And in late 2024, a research team brought up a scanner that aerospace factories use to verify jet engines, and aimed it at one. What the scan found inside those H-blocks isn't supposed to be possible. Not 1,500 years ago, not at this altitude, not by anyone we have a name for. The site that never made sense.
These are the mysterious ruins of Puma Punku, nearly 13,000 feet in the Altiplano of Bolivia.
For 120 years, mainstream archaeology has been pretending the problem isn't there. Walk this plateau and you'll see why. 12,800 feet up, on a windswept shore of Lake Titicaca, sits a scattered pile of stone blocks that does not make sense. And a century of archaeologists have left with more questions than they came in with. The blocks are made of andesite and red sandstone, two of the hardest stones in the region.
These are the mysterious ruins of Puma Punku, high in the Altiplano of Bolivia.
They are cut with angles so precise, surfaces so flat, and internal geometry so complex that the structure they originally formed has never been successfully reconstructed. Not by the Bolivian government, not by international teams, not by anyone with a 3D modeling program and the full set of surviving pieces. The site is called Puma Punku. Its builders are called the Tiwanaku. And what they did or did not do at 12,800 feet between roughly 300 and 900 AD remains one of the most uncomfortable, unsolved problems in world archaeology. The official explanation has been the same for over a century. The Tiwanaku were a skilled pre-Columbian civilization with stone tools, copper implements, abrasive sand, and a lot of time. They quarried the H-blocks, dragged them to the site using ramps and ropes, and shaped them with handheld chisels until they fit together. Case closed. Except nobody has ever made that explanation actually work. And what that scanner read off the H-block in late 2024 is the reason the case will not stay closed. The scanner, the H-block, and the pause.
Arthur Posnansky was a researcher, part Bolivian, and he had worked at the site for many decades. And he concluded that the site must have been built about 17,000 years ago by studying the archaeoastronomy of that particular site.
Picture the scene again. The team kneels in the thin air. They've already calibrated the unit twice because the elevation makes everything harder, including the equipment. The structured light 3D scanner they brought up the mountain is aerospace grade, capable of measuring surface irregularities down to 0.01 millimeters, tighter than the tolerance required for a modern aircraft engine. They aim it at an H-block. The grid of light deforms across the andesite. The software runs the comparison. The screen returns a number nobody can square with the textbook. You'll get the exact figure in a moment. First, you need to understand what an H-block is. Viewed from above, an H-block roughly resembles the letter H. Two vertical elements connected by a horizontal crossbar. Each is carved from a single piece of stone, with a complex interior geometry of grooves, notches, and recesses cut into surfaces that shouldn't be cuttable with the tools the Tiwanaku are supposed to have had. The blocks are clearly designed to interlock. Protrusions on one fit into recesses on another. No mortar required, the geometry itself locking them in place. They are the artifacts that 120 years of scholars have argued over the most. So, when that European geoarchaeology team finally turned a sub-millimeter scanner on the inside of one, they were aiming straight at the unsolved problem. What did the screen say? Hold that. To feel the impact, you need to know who supposedly cut these things. Who the Tiwanaku were, and what they weren't. Here's the thing you have to understand. The Tiwanaku were not nothing. They emerged in the high Andes around 300 AD, centered on the southern shore of Lake Titicaca, the highest navigable lake in the world. At their peak, between roughly 500 and 900 AD, They controlled territory stretching from the Bolivian Altiplano into parts of modern Peru, Chile, and Argentina. They were an organized state-level society with sophisticated agriculture, extensive trade networks, and monumental architecture. Their capital, also called Tiwanaku, may have held 20,000 to 40,000 people. They built terrace fields, developed raised field agriculture in the thin mountain air, and carved stone statues that still stand today, including the famous Bennett monolith, more than 24 feet tall. The Tiwanaku were real. Their achievements were significant. Nobody serious disputes any of that. What people dispute, and what the H-blocks force us to dispute, is whether these particular people could have done what was done at Puma Punku. The main Tiwanaku complex, located about a quarter-mile away, contains impressive but comprehensible architecture. Stone walls, terraces, temples, construction that fits within the expected capabilities of a Bronze Age civilization. Puma Punku doesn't fit, and the H-blocks fit least of all. The stone that shouldn't yield.
Archaeologists are baffled by this structure. They don't know what was here or what the purpose.
Here's the part most people don't realize. The H-blocks at Puma Punku are cut with a precision that appears elsewhere in the ancient world, only at sites like the Serapeum of Saqqara in Egypt, or the finest Inca stonework at Cusco and Ollantaytambo. The surfaces are flat to degrees that challenge measurement. The angles are consistent across multiple blocks, as if cut from templates. The internal grooves and interlocking notches suggest a construction system no one has been able to reverse engineer. And the material is the problem. Andesite measures 6 to 7 on the Mohs hardness scale, while copper measures only 3, meaning the tool wears down faster than the stone, which is why every realistic estimate puts a single rough cut at months of pounding work. So the result should look like exactly that. Rough, laborious, hand-marked. It doesn't. Surfaces so uniform they appear machine-made. Corners so sharp they could cut paper. Grooves so consistent they seem stamped rather than carved. The craftsmanship exceeds the tools. The precision exceeds the technology. The results exceed the explanation. That's the contradiction the scanner was sent up the mountain to measure. Quick word before we go deeper. If you've made it this far, you already feel it. The H-blocks aren't behaving the way Bronze Age artifacts are supposed to behave. We dig into sites like this every week, stories where the precision shouldn't be possible, and the standard explanation collapses the moment somebody points an instrument at the stone. Hit subscribe. The next investigation is already filmed. Now, back to the H-block. The man who spent 50 years staring at these stones. Before we open the 2024 scan data, you have to know about Arthur Posnansky, because what that scanner measured, Posnansky was already arguing about 100 years earlier, with calipers and a notebook. Posnansky was an Austrian-Bolivian engineer and amateur archaeologist who became obsessed with Puma Punku in the early 20th century. He spent over 50 years on this site, surveying the ruins, documenting the H-blocks, and developing theories that mainstream archaeology has never accepted. His most controversial claim involved astronomical alignments. Posnansky believed certain structures at Tiwanaku were oriented towards solstices, equinoxes, and stellar risings, and that by calculating the precession of the Earth's axis, he could date the original construction. His conclusion: the site was built around 15,000 BCE. That date is rejected by virtually all modern archaeologists. Radiocarbon dating of organic materials at the site consistently returns dates between 300 and 900 AD, and his 15,000 BCE figure is treated as pseudoscience. But here's what's harder to dismiss: his observations about the stonework itself. Posnansky measured angles and surfaces and recorded the results. And he concluded the craftsmanship exceeded what Stone Age or Bronze Age technology should have been capable of producing. Decades later, modern researchers brought better tools. Christopher Dunn, the American engineer who'd built a career measuring tolerances on aerospace components, walked the Puma Punku field with precision squares and depth gauges, and reported that the inside corners of the H-blocks were tighter than anything he'd expect on hand-cut stone. Brian Forrester, the independent investigator who has spent years filming on the Altiplano, has held a straight edge against the flat faces of the H-blocks on camera and shown gaps so small you cannot see daylight through them. These aren't fringe rumors. These are men with tools on the stones, recording what they read. And what they read pointed in the direction the European scanner would later confirm in mathematics. Why the standard explanation collapses.
In Puma Punku, the stone seems vitrified too. It is so smooth, it's as if you touch a bathroom mirror.
Here's where the official story really starts to wobble. The mainstream explanation involves diorite. Diorite measures 6 to 7 on the Mohs scale, roughly equivalent to andesite. Mainstream archaeologists propose the Tiwanaku used diorite hammerstones to pound away at the andesite, slowly shaping the H-blocks through endless repetitive percussion. The technique is real. It was used at the granite quarries of Aswan in Egypt, where the unfinished obelisk shows clear evidence of diorite pounding, rough surfaces, irregular tool marks, slow progress as workers remove material bit by bit. The hypothesis is plausible. The problem is that it doesn't explain what we see at Puma Punku. Diorite pounding produces rough surfaces. It does not create the polished, geometrically flat faces found on the H-blocks. To get there, the Tiwanaku would have needed grinding, polishing, abrasive sanding. The Egyptians used those finishing techniques to polish granite to a mirror finish. But the Egyptian examples took years, decades possibly. The labor investment was enormous, reserved for the most sacred objects. At Puma Punku, the precision isn't limited to a few showcase pieces. It appears across hundreds of blocks. The H-blocks exhibit identical precision across multiple examples, as if produced on an assembly line. Stop and feel that. Hand finishing produces variation. The hand of the individual craftsman is always visible in handwork. At Puma Punku, that hand is invisible. What's visible is standardization, manufacturing precision, suggesting some method of achieving consistent results across the entire scattered field of H-blocks. And whatever that method was, the answer is somewhere inside the scan data. The H-block puzzle that will not solve. The H-blocks are clearly designed to interlock. The geometry was meant to lock them in place without mortar. But here's the part that sits in your chest. The blocks don't all fit together. Some match, others don't. Dimensions vary slightly from piece to piece, as if different batches were produced to different specifications, or as if the site was never completed, or as if pieces are missing. Despite 120 years of study, no one has successfully reconstructed what Puma Punku originally looked like. Computer models, physical reconstructions, international teams, none have succeeded. That last possibility is the one that haunts the site. What if Puma Punku was never finished? What if the H-blocks were manufactured, transported, and abandoned before assembly? Manufactured, transported, abandoned. It would explain why the pieces don't fit, why the dimensions vary, why the site looks less like a ruined building and more like a workshop floor scattered with components. But then why were they abandoned? The Tiwanaku civilization didn't end suddenly. It declined gradually over centuries, eventually fragmenting into smaller polities later absorbed by the Inca. There was no catastrophe, no invasion, no dramatic ending that would explain why a massive construction project was left incomplete. Unless the project wasn't Tiwanaku at all, unless the Tiwanaku found the H-blocks already there, already cut, already scattered, and tried to understand what an earlier people had built. That hypothesis is heretical to mainstream archaeology. It implies an unknown predecessor civilization, but it would explain the precision that exceeds Tiwanaku technology, the unfinished state, and the sense every visitor reports, that two different levels of craftsmanship are present at the site. If somebody else cut these H-blocks first, the next question is whether they could have done it at all up there, because the place they did it in is its own form of evidence. The altitude problem nobody wants to talk about. The elevation of Puma Punku is not a minor detail. At 12,800 feet, the air contains roughly 40% less oxygen than at sea level. Modern workers at this altitude tire quickly and accomplish less per hour. Now, do this math with me. Some H-blocks weigh over 100 tons. The The nearest quarry sources for the andesite are approximately 10 miles away across terrain that includes ravines, slopes, and areas without roads. The red sandstone came from even farther. Some estimates place the source over 50 miles distant. So, how did the Tiwanaku move 100-ton blocks across 50 miles of Andean terrain at altitudes where breathing is difficult, and arrive with the stones still pristine enough to be cut to the tolerances we keep measuring? The standard answer is manpower. Lots of it. Ramps, rollers, ropes, thousands of workers pulling together. The pyramids of Egypt prove that human muscle, properly organized, can move stones of almost any size. But the pyramids were built at sea level, with access to the Nile, in a wealthy empire that could command resources from across an entire region. The Tiwanaku were impressive. They were not Egypt, and they still would have needed to cut the H-blocks with precision exceeding what their technology should have allowed. 100 tons, 50 miles, 12,800 feet. Read that line again, then ask yourself which is harder to swallow. That the Tiwanaku had capabilities we don't understand, or that they didn't actually do this, because that's the choice the scanner is about to force. What the 2024 scan actually found inside the H-blocks. Now we open the data. Earlier measurements at Puma Punku used hand tools, calipers, straight edges, equipment capable of detecting variations down to perhaps a millimeter, precise by everyday standards, not precise enough to characterize what researchers were observing. The structured light 3D scanner, used in late 2024, works by projecting patterns of light onto a surface and analyzing how those patterns deform. It calculates surface geometry down to 0.01 millimeters, roughly 1/10 the thickness of a human hair. It's the technology aerospace and automotive manufacturing use to verify components meet spec. The team scanned multiple H-blocks, the grooves, the corner joints nobody has ever satisfactorily explained. And here is what their screens kept returning. The surfaces are flat to within 0.05 millimeters across spans of several feet. Read that again. Not approximately flat, not visually flat. Engineering flat. The kind of flatness you achieve with precision grinding machines or surface plates. Not with hand tools and abrasive sand on a windy plateau 2.5 miles up. The internal corners of the H-blocks meet at angles that deviate from 90 degrees by less than 0.1 degree. The kind of precision modern machinists specify when parts need to fit together without gaps or wobble. The grooves hold consistent depth to within 0.1 millimeters across their entire length. Walls parallel, floors flat. These measurements do not match what stone tools and manual labor produce. They match what machine tools and industrial processes produce. The researchers were careful. They documented the measurements without claiming to know how the precision was achieved, but the data speaks for itself. Either the Tiwanaku developed manufacturing techniques far more sophisticated than anything archaeology has documented, or the standard explanation for Puma Punku is wrong. Once you've seen those numbers, the next question is whether the timeline itself can hold them. The timeline that keeps getting rewritten. The mainstream timeline is familiar. Humans crossed from Asia to the Americas via the Bering Land Bridge approximately 15,000 to 20,000 years ago. They reached South America perhaps 12,000 to 14,000 years ago. The first complex societies in the Andes, the Norte Chico or Caral Supe civilization, emerged around 3000 BCE. But the timeline keeps being revised. Recent discoveries at Monteverde in Chile suggest human presence in South America as early as 18,500 years ago. Footprints discovered at White Sands in New Mexico in 2021 have been dated to over 21,000 years ago, pushing back human presence in the Americas by millennia. The question isn't whether the timeline might be wrong. The question is how wrong. If humans arrived earlier, they had more time to develop, more complex achievements become possible. And H-blocks flat to 0.05 millimeters begin to make a different kind of sense. Posnansky's 15,000 BCE date is almost certainly wrong, but what if his intuition was partially correct? What if the site contains layers, later Tiwanaku construction built on top of earlier foundations? What if the H-blocks represent an earlier phase the Tiwanaku inherited rather than created? It would explain why Puma Punku seems different from the main Tiwanaku complex, and why the H-blocks appear unfinished. Perhaps because the Tiwanaku were attempting to continue a project they didn't fully understand. It remains a hypothesis. There is no direct evidence of pre-Tiwanaku construction, but the precision measurements keep pointing toward capabilities the Tiwanaku should not have possessed. So the next question is, what condition this evidence is even in for us to read? What the stones will not tell us. Puma Punku today is a UNESCO World Heritage location. That word, protected, is generous. Over the centuries, the site has been looted, vandalized, and dismantled. Spanish colonizers used H-blocks as building material. Local farmers carted away stones. Earthquakes toppled structures and scattered components across the plateau. What we see today is not what the original builders created. It's a debris field, a puzzle with missing pieces, a ruin of a ruin. The 0.05 millimeter precision that survives may be only a fraction of what originally existed. The history of archaeology is a history of underestimation. The Maya could not have built their cities in the jungle until LiDAR revealed cities larger than we imagined. The Egyptians could not have achieved precision in their stonework until engineers measured tolerances that challenged modern replication. The Greeks could not have built mechanical computers until the Antikythera mechanism emerged from the sea. Puma Punku may be the next correction, not proof of aliens or lost continents. Proof of human capability we have systematically underestimated. Whoever they were, they looked up at the stars from 12,800 feet above sea level. They cut H-blocks to tolerances that match industrial standards. They created interlocking shapes that fit together in ways we can't reconstruct. They did all of this in thin mountain air, against every obstacle their environment placed in their way. And then they left. The knowledge that created the H-blocks was not passed down. By the time the Spanish arrived, even the Inca didn't know who had built the stone monuments on the Altiplano. The Inca attributed the construction to the gods. They may have been closer to the truth than they realized. Not because gods literally built Puma Punku, but because whoever did possessed capabilities so far beyond their own that the difference seemed divine. The 2024 scans quantified that difference. 0.05 millimeters of flatness, 0.1 degrees of angle, 0.1 millimeters of groove depth. But quantifying isn't understanding. We know how flat the surfaces are. We don't know how they were made flat. The measurements are in. The mystery remains. Puma Punku sits on its windswept plateau, 12,800 feet above sea level, keeping its secrets. The H-blocks do not explain themselves, the stones do not speak, and the people who cut them, whoever they were, whenever they lived, whatever tools they used, left no record. Just the work itself, precise, impossible, silent. What was Puma Punku? Who really built it? And what did they know that we have forgotten? Drop a comment with what you think those H-blocks were really for. Hit like, hit subscribe, and turn on notifications because the next investigation is already in the works. And remember this, somebody at 12,800 feet, with their bare hands or with something we still can't name, knew exactly what they were doing. The stones say so. We just can't read the language yet.